Welcome back to a new video in my ModernGX tutorial. Last video we have created that window that's gonna open up in a few seconds. And I mean that window. It's just a full screen black window and it looks like it's working, but it's actually not correct because our buffer is never been bound as render target, nor is the buffer never cleared. And we're gonna do that in this video, and we're gonna start writing some drawing code, and depending on how long this takes, we may actually get some something on the screen today. Alright, first of all, we're gonna do some window keep-up, some working on the window. So the first thing that we need is we need to prepare current buffer as render target. Later on, we need to prepare current buffer for presenting, because we want to present on here. So there are basically two things that we need to do, or actually there are more, and actually if you take a look at Vertex 12, it's even much more. But I tried to make it as simple as possible. First of all, let's just take a look at our comment list and see what functions it provides. It provides not every function that is required for DirectX, but a few where we can get started. And actually, it provides a function called om prepare Rtds views. This function actually handles everything, clearing the render target and binding the render target. The only thing it requires is a CPU descriptor handle to that render target view. Now, this is actually one of these three handles that we have allocated here. And actually the window, because it is managing these handles, we can ask the window to get the current buffer index, or the render target view CPU handle, which is exactly what we are looking for. So this one single call will clear and bind the render target. The only thing that this command is not able to do is, or this function better to say, is setting the state of the render target. By default, the render target, the buffer of the render target, is at a state that is called present. When we want to render to that, we need to set it as to the state render target, and later on when we are done rendering, we need to set it back to the state present. And this is DirectX done with a resource barrier, but basically ModernGX does it the same way. But ModernGX supports resource barrier grouping. So basically, internally, the comment list manages a list of resource barriers. And as soon as you hit a comment that requires all previously recorded resource barriers to be flushed, or to be executed, better to say, then it will bundle them all up together in one single call to the resource barrier DirectX 12 function. And since this is all done internally, we need to kind of like get this resource barrier from the comment list. And actually, the comment list provides four functions. It has resource barrier peek and push, and flush. Peek means looking at the next barrier that can be used. So if you call the function peek, you get a pointer to a D3D12 resource barrier that you then can use to fill in some informations. Important is when you actually use that buffer or that barrier that you peeked with the peek function, you need to call push afterwards. If you don't call push, it may get overwritten by the next call to peek, or it might get overwritten, or it might not just get sent to the GPU. There's also this function peek and push that is basically returning you a pointer to a resource barrier and internally already marking that this is being used. If you are 100% sure that a state change is actually being triggered, or if you are doing things manually, if you're manually introducing a resource barrier and you know you're going to write to that no matter what, this function is actually 100% fine. But most of the time, especially internally in the library, I'm doing resource barriers as often as possible. So maybe basically every single copy command does try to create a resource barrier, but actually the resource itself can say, okay, no, I'm already on the correct state, and then it returns false, and then I'm just not calling the push function. But for our case, the peek and push function is actually fine. The flush function is a special function there. The flush function basically makes sure that all resource barriers are written. As long as you are only calling the dot function, so with the dot functions, normal functions on the managed comment list here, then you are good. If you actually go in and to use the pointer operator to get to the raw DirectX 12 functions, or you use the pointer function to get to the raw DirectX 12 functions, then you're gonna need to make sure that you flash resource barriers on your own. So basically, if I would go in there and say draw, so doing a raw DirectX 12 draw call, I would need to make sure that I call resource barrier flush before. But in case I'm using the internally draw, the internal provided draw function, this one is actually gonna check and manually flush or automatically flush the resource barrier internally. Alright, so we are looking for the resource barrier peek and push function because we know that we introduce a state change and it is a bit more easier from the standpoint of coding. But how do we actually how can we actually change the resource state of the back buffer? Well, it's actually quite easy. We can ask our window to get the current buffer, so that we get the current active back buffer. And what we can do then is we can say set resource state to set a new state as for this resource. And in this case, I wanna go for the resource state render target. And I need to provide a resource barrier as well, which I'm obtaining through the resource barrier peek and push function. And after that call, we are good. Now there is also, we need to also call this function again down here because we need to go back to present. Just like that, and now we are actually good in terms of state changes. One thing that is now required is executing the comment list. Because now we're actually using the comment list and doing comments on them. This is very easy. First of all, we need to close the comment list. This makes also sure that every pending resource barrier gets flushed. So we just call comment list.close. After this, we are asking our comment queue to execute our comment list. Very straightforward. This returns an uint64 that we then can feed into another call to the comment queue, the wait function to the comment queue, which basically waits for a previously executed execute, returned basically given or introduced by the uint64 fence value. And after we are done with the comment list, after it has been executed, we need to reset it to make sure that it has been usable for the next frame. Now in between here, we bind states and we draw triangles. But we're gonna get to that. Let's execute this and see what this is gonna do. It's not gonna do anything noticeable because, well, we are still black. If we would clear our render target to a different color, we would see any changes, but basically this is exactly what we need. We need these functions even though we don't see anything. Alright, so the next thing that we need to do is we need to bind several things at the comment list to draw something. So first of all, we have several types of bindables that are existing. We have the input assembler, we have the output merger, and we have the rasterizer that we need to bind as static state. The input assembler sets the buffer, so vertex buffer, and the topology. We cannot do this for now. Just gonna comment this out here because we cannot do this because we don't have a vertex buffer yet. What we also need to do is we need to set the rasterizer. We need to set a viewport and rect. We're going to use the second function, pointer to a viewport and pointer to a rect. These viewport and this rect are actually dependent on the window. So we can actually ask our window to give us a rect, which is the window rect, which we can easily obtain by asking our window to get the scissor rect. Actually, let's also call this window, not windows, we're gonna call this window scissor rect. So we're gonna ask our window to provide us a scissor rect, and we also need the viewport. And we also have this window viewport here, and we also are gonna ask our window to get a viewport. This will always cover the full window, so if you want to actually manually just draw on a portion of the window, you need to manually supply different values here. manually build these or alter these rectangles. But we're gonna just do this like that so that we can draw on the full window. One thing to be noted, when we resize our window, it gets other dimensions, so we need to make sure to recreate the window scissor rectangle and the window viewport when we resize our window, which can just be easily done by pasting these two lines there without the definition. Now we can easily plug them in here. First of all, we need the window viewport, so window viewport, pointer to window viewport, and a pointer to the window window scissor rectangle. There we go. Now we have set our scissor rectangle and we have prepared our output merger. So we have a render target bound. The rasterizer knows how to render to that render target. Now is missing the input assembler that is actually feeding in the triangles and the format for those triangles. And to do that, we need to first of all actually describe our vertex buffer. So we need to declare a vertex buffer type. So vertex buffer. We're gonna have a struct here. I'm just gonna call this vertex, and it's just gonna have some x and y coordinates because we're just gonna draw 2D in this tutorial. So just two floating point numbers, x and y. Now let me also create an array. Let's make this const vertex. Let's call these, so we're gonna call them quad vertices, and we're just gonna plug in some data here. So let's just do this like that. And we now need to provide some coordinates. Now, just to kind of like show you that. So when you draw a quad, you need to kind of like compose this in DirectX out of two triangles. And the most easy thing to draw a quad is basically dividing it in half by a line and saying, okay, we're gonna have two triangles, we're gonna have the triangle 1 and we're gonna have the triangle 2. This gives us kind of like 4 vertices of that for that quad. But to describe two triangles, we would need to manually say 2, 1, 1, 1, 1, 2, 1, 3. Then for the second vertex, or for the second triangle, we would need to go to 2, 2, 2, 3, and 2, 4. Let me just quickly write the indices here as well. So let's say 1, 2, 3, and 4. And to draw the triangles, we would need to kind of like specify 3 vertices for that triangle 1, and we would need to specify 3 vertices for the triangle 2. But actually, as you can see, we have double vertices in there. So, well, it's actually not the best idea to use 6 vertices. I mean, who cares actually? So it's actually quite ridiculous to make this smaller. But the thing is, I'm not trying to make this like smaller down to 4 vertices or using indices there. I'm not trying to make this smaller because of memory. I'm trying to make this smaller because I'm lazy to type. And the idea is basically that we are using a triangle stripe. So a triangle stripe works like that. You specify 3 initial vertices, 1, 2, 3. They make up the first triangle, that one. After that, the first vertice that you have defined gets dropped. And this next one, this fourth one, gets added to the list. So then you have again 3 vertices, and these make up the next triangle. So basically this would be kind of like 1, 2, 3, 4. You would define it 1, 2, 3, 4 in the vertex buffer. And then basically, well, how the GPU would do it, it will take the first 3 for the first vertex, and then for the first triangle, for the first 3 for the first triangle, and the next 3 from the second to the fourth for the second triangle. And well, this is exactly how we're gonna do this. So we're gonna start by the bottom left triangle, which is at -1.1, or let's just do, yeah, let's just do -1.1 float, -1.1 float. Double that, or maybe let's add something there that's looking a bit nicer. Now we want to actually, because we need to take winding direction into account, now we want to go the vertex up, so the top left vertex, which has an x coordinate of still -1, but a y coordinate of 1, so having a 1 in there. Double that again. Now we are taking the bottom right of that. That has again a y coordinate of minus, but an x coordinate of plus, which then makes up that one. Now we would drop that one, the first vertex, which gives us the top left and the bottom right. Now we need the top right there, which is basically just all coordinates at 1. And this basically gives us vertices for a quad. And now we need to make, or we need to copy that somehow to the GPU. We need several stuff for that. First of all, we need a buffer on the GPU. It is actually stored here in GPU types, and it's called G-type buffer. So this is basically a buffer on the GPU. Now let's actually create one of these. So Vertex Buffer core. G-type stands for types on the GPU, and we are looking for a buffer. And buffer that we're gonna use is being called Vertex Buffer. And we're gonna create it with our device. Do I have some IntelliSense available? I don't know why IntelliSense is hating me. There it goes. Now, resource creation in ModernGX can be done in 3 ways. Most of the time. It can be reserved resources, which means virtual, but reserved resources is basically not often used most of the time for textures, for doing virtual texturing and stuff like that. But also for different types, most of the time virtual texturing for textures, not for buffers. The other 2 types are committed in place resources. So you could actually go the route and create a manual heap. The heap will have its own memory management, and you can allocate things from the heap. And basically this would mean that you need to provide a heap allocation cookie that tells kind of like ModernGX on which heap you want to place that resource. But we're gonna go that hard route. We're gonna create the buffer very straightforward. We're just gonna do it as committed resource, so basically just managed by DirectX 12. And to use committed resources, we need to specify a usage, so a heap usage. And we're gonna use it as a default heap, or place it on a default heap, because we just wanna put it on the GPU memory, so on the local memory of the GPU, that we can use it as a vertex buffer. Next thing that we need to provide is a size. So we want to place vertices on that, and we want to actually place 4 vertices in there. So we're just going to create a vertex buffer for 4 vertices. Now the thing is, we need to get the data to the GPU somehow. And we can do this with a upload buffer. So let's include some more things here. And we're gonna include a, was it called? It's not in core, it should be in helpers, GPU upload stack. So this helper basically manages uploading data to the GPU. So upload buffer. So you're gonna go to helpers, GPU upload stack. I'm just gonna call this upload buffer. So basically, you of course need the device again, and the other parameter is actually the size. So this would be, I want to make this a bit bigger because we are also gonna upload some textures at a point. So I'm just gonna make this sufficient enough. This would be 1 kilobyte. This would be 1 megabyte, and we're gonna go for 16 megabytes here for this upload buffer. All right. Now we need to actually upload data to the Vertex Buffer. We can do this by asking our upload buffer. Actually, first we need to initialize our upload buffer. So we call the reset function on our upload buffer, and we need to specify a comment list. And we're gonna input our comment list. This is resetting the buffer and making sure it's in the correct state. And this buffer will from now on use this comment list for uploading data. Now we're gonna ask this upload buffer to copy something to a buffer. We wanna copy to our vertex buffer. And we wanna copy our quad vertices. So we're gonna have our quad vertices there. Then size will be again size of vertex times 4. And we're not gonna have any offsets, so this should be good. By the way, most of these functions, like copy buffer, return a boolean, which you could check to assert that you are good, but I'm doing error checking in this tutorial just to make things a bit easier. Alright, so basically calling this function should make sure that everything, or that this call should make sure that our buffer has the correct data on the GPU. One thing that I want to introduce down here is I want to set resource states, because of course the buffer cannot stay in the state after we have uploaded it. The buffer needs to be manually placed back to a different resource state. So state, we want to have the resource state vertex and constant buffer, because this is a vertex buffer. And we're gonna ask our command list to resource barrier peek and push, because I know that's gonna work like that, and this should be good. One final thing that we need to do, we need to close the upload buffer. This is done by calling the upload buffer close function. This just makes sure that all open CPU-sided resources, so basically there is a map pointer to the actual buffer that is maintained by this upload stack. And this just makes sure that it is closed so that the API can correctly operate on that as soon as the command list is executed. And speaking of command list execution, well, actually we don't need to take care that we have a separate execute. It will be executed when we first come to that. Alright, so now we have our Vertex Buffer up and running. One thing that is missing is a Vertex Buffer view. So we need to create one. And we can just create some simple Vertex Buffer view, because it's like a descriptor CPU-sided. Just gonna call this Vertex Buffer view. And I'm gonna set this by asking, not my upload buffer, I'm setting this by asking my Vertex Buffer to create a Vertex Buffer view. And actually this is templated. This just makes it a bit easier to do things. Of course we need to provide the pointer to the Vertex Buffer view. And this just, I mean, the templates are just kind of like computing the stride. Just therefore doing the strides and the total size with just a count. So yeah, we can be here very good by just using that. Alright, so this is how we do that. Now basically what we have done is we have properly uploaded our Vertex Buffer and set all the resource states for that Vertex Buffer. Now we need to bind it to the GPU. This is where this function comes into play, so we're gonna input the Vertex Buffer view here. And one thing that is missing is a primitive topology. By default it's using a triangle list, but as I showed you in Paint earlier, we have a so-called triangle strip. And we need to manually specify this. If we would normally use normal triangles, this would be sufficient. But we are using a triangle strip. D3D10, primitive topology triangle strip. So now we are actually good. Now there are actually more things missing. We need to bind a state and a root signature. And then we need to draw triangles. Drawing triangles is actually then straightforward. We can just simply call draw. We have 4 vertices to draw, so yeah, this would be it. But this is not gonna work because we don't have any pipeline state and programs bound. It's probably saying, yeah, no pipeline state has been set. And it's gonna use this default no operation pipeline state. So basically the GPU is doing nothing. It's just idling. We can actually still use Inside Graphics to verify that everything else we have done has been done correctly. One thing that's very important when you are using Inside Graphics is that you switch to release, because Inside Graphics cannot handle the debug layer. So I'm gonna do a build here. So I'm just gonna hit F11 to do a capture here, and when we go now into Inside Graphics, you can actually see that how you're actually like, this is everything that you have done, and most of the things have been actually done by ModernGX. But you go to frame debugger or resources, and you're going to be presented with 2 buffers. I mean, these are the back buffers, okay, but I'm more looking for these buffers here, these 2. You can actually see that there are multiple revisions because it has already drawn geometry, and the geometry was actually legit. You can see this maybe in a second. Actually, these buffers are 2 different buffers. First of all, this is the copy source buffer, and it is an upload buffer. So basically, this is not the buffer we are looking for. We are looking for this buffer 2, which is the default buffer. And if we take a look in here, we see some data. And if I go to configure and just display this as a float 2, you can see that we have the -1, -1, -1, 1, 1, -1, and 1, 1, which is exactly what we have set up on our buffer. So you can see like the GPU has proper data available. And if I go into the frame replay, we might even have the geometry somewhere. Okay, no, we don't have it because it's probably been discarded because we have this no-op pipeline state. But yeah, we're gonna see this in the next video. So yeah, sorry, no drawing today, but next video we're gonna draw some drawing. Next video we're gonna discuss the pipeline state and root signature. So yeah, thank you for watching. See you in the next video. Have a nice day, and until then, bye.